like to show you something pretty neat that we can do with the derivative now, and it's called L'Hopital's rule. So take a look at the graph that we have over here on the right, and we have two what appears to be linear functions here, one with a positive slope, one with a negative slope. And we're going to let the grid markings represent the same scale. So let's just make each grid marking 1 unit, okay, for both our x-axis and our y-axis as well. We're going to call the function that has the positive slope, that's going to be f of x, and the function with the negative slope is going to be g of x. So can you please pause the video and look at the look to see how many of the questions you can answer for 1 through 6. Do the best that you can, and when you're done, unpause the video and match up your answers with what you see. So for starters, it says, what's the slope of the graph of f? Right? Well, we can see that for every 1 unit we go up and we go 1 unit over. Up 1 over 1, up 1 over 1. So we rise up 1 and we run over 1. So the slope of the graph of f is going to be 1. How about the slope of the graph of g? Well, here's a spot. In g we go down 1 and over 2, down 1 and over 2. So we can see the slope of g is a half, but because we have a decreasing function, it's negative slope. Alright, number 3 says, let the intersection of the two graphs be the point A0. Use the slope information from above here and come up with equations for both f of x and g of x. So let's do f of x first. Right? So we're going to write the equation of a line, so that's y minus y1 equals m times x minus x1. And we know that x1 is a and y1 is 0. So we have for our f function, we have y minus 0 equals, the slope we said was 1, and then we have x minus a. A is just some number. It could 1, 2, 3, 4, 5. It might be 5, it might be a little less than that. We're not quite sure, but it doesn't really matter. It's just some number. And so this can be simplified. We don't need the minus 0 there, so we end up having y minus equals x minus a. And again, this is our f of x function. So what we really have here for f of x is f of x equals x minus a. All right. We're going to do the same thing for g of x. All right. So again, we're going to have y minus 0, or excuse me, yep, equals, and now we're going to plug in our slope for g, which is negative a half. And then we have our x minus a. And we can simplify that to y equals negative 1/2 x plus 1/2 a, or a over 2 if you prefer. And that's our g function, so that means that g of x is negative 1/2 x plus 1/2 a. So there's our equations for f and g. And box those off. 1 and 2. Okay, so next up, use the grid to find the ratio of f of x over g of x for 4 values of x that are different than this point right here. All right. So let's pick this value right here for starters. Okay. So we want the ratio of f to g. All right. Well, in this x right here, f's value is negative 4. It's down there. So f is negative 4, and g is up 1, up 2. So that simplifies to negative 2. Right. Right. Now, how about if we go to this value of x right here? At that value right there, f is down 1, down 2 units. So f is negative 2, and g is, going back and forth on the screen, up 1 right there. All right, so g is 1. And again, that's going to simplify to negative 2. Now we don't want to pick this value because we have to pick values other than this one, and that wouldn't really work anyways because we'd have 0 over 0. We don't want to divide by 0. But this value right here, now f is 2 units up and g is 1 unit down. So we're going to have 2 over negative 1, which is also negative 2. And you get the idea here. No matter what, it seems like, I know I said 4, but if we got 3 here, we can see that they're all negative 2. And that's going to be the case in general. All right, so no matter what, when we look at the ratio of f of x over g of x, we're looking at -2. So based off of these answers, what do you think the limit's going to be as x approaches a of f of x over g of x? Okay, well, we know if we go to the picture, all right, f of x is 0, and g of x is 0. So we're going to get 0 over 0. But based off of everything else that we see here, the limit seems to be -2. Right? So there's our reasoning. You know, our reasoning is basically all of this up here. Every other ratio was -2, so this ratio should be -2 as well, even though it really turned out to be 0 over 0. So how do we get this -2? Well, back in questions 1 and 2, you found the slopes of f and g. What is the ratio of the slope of the graph of f to the slope of the graph of g? Here's your slope of f. Here's your slope of g. So to find this ratio, we have 1 over -1/2, which is -2. So look at that. The ratio of the functions was -2, and the ratio of the slopes of the functions was -2. But if we're talking about the slope of a graph at any point, what is the slope of the graph at any point? Exactly, it's the derivative. So let's look at, when we're finding the limit as x approaches a of f of x over g of x, okay, well, that we already know what f of x is. F of x is x minus a. We found that in part 3. All right, and g of x is -1/2 x plus 1/2 a. We found that also in part 3. Those are the functions. What if we looked at the ratio of their derivatives? What's the derivative of x minus a? Yeah, it's 1. What's the derivative of -1/2 x plus 1/2 a? Yes, -1/2. And now we don't need to plug in the a at all. We can see that this simplifies to -2. That is L'Hopital's rule. In our notes at the top of the next page, right, L'Hopital said, hey, suppose that if you take a limit and you plug in a, and f of a and g of a both happen to be 0. As long as f and g are both differentiable on the open interval, then guess what? The limit as x approaches a of f of x over g of x, that's equal to the limit as x approaches a of f prime of x over g prime of x. L'Hopital's rule says that if you get 0 over 0 when you plug in a value on a limit, like you did way back in September, well, that's okay. You don't have to do any algebra. All you need to do is derive the numerator, derive the denominator, and then plug a in again. You hopefully will get an answer. And if you don't, that's okay. You can do it another time. This is equal to the limit as x approaches a of f double prime of x over g double prime of x, if this still happens to be 0 over 0. And it will go on and on and on. As long as you get 0 over 0, you can just keep deriving until you no longer get 0 over 0. That's L'Hopital's rule. Check out the next video for some examples where we put L'Hopital's rule to good use.